Hello everyone. Yesterday we were discussing about the mathematics topic sets. Now we discussed that set is a well-defined collection of objects, and in mathematics we denote some standard sets by using these letters. For example, set of natural numbers we denote these by letter N, and set of integers, whether positive or negative, we denote it by Z. And to denote positive integers we put a positive sign over the Z. Then we denote a set of rational numbers with the letter Q. Rational number means P by Q form, where Q is not equal to 0. For positive rational numbers we put a positive sign over the Q. Then T denotes the set of irrational numbers. Irrational number means a number which cannot be represented in the form of P by Q. And then R denotes the set of real numbers. Real numbers means the collectively the rational and irrational number together, they are known as real numbers, right? Now one more thing, that element order is irrelevant in a set. Means what? If set A is written as ABC and then set B is written as CBA, then both the sets are same only. We denote that A element belongs to set A. This symbol is called as epsilon, which indicates this element A belongs to set A, and we put a slash if this element does not belong to set A. Now for example, find the solution set of x square minus 9 is equal to 0. We can calculate this value of x as x square is equal to 9, then x is equal to root 9. X comes out to be plus minus 3. This is the solution set of the polynomial equation. Right? Another example we have taken. This is a roster form of a set 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6. And in the set builder form, we can represent A as equal to x such that x is equal to n by n plus 1, where n lies between 1 to 5. Because you can see this, that numerator is 1 less than the denominator, or we can say the denominator is 1 more than the numerator. So we have written in the generalized form n, and in the denominator we have written n plus 1, means that the denominator is 1 more than the numerator. Then coming to the classification of sets, the first type of set is an empty set. It is denoted by a symbol phi, or we can simply put parenthesis without writing any element. Now what kind of sets are empty set? A set having no elements. Example, A is equal to x such that x is square of a natural number and x is less than 0. Now you know that x is if x is the square of a natural number, the square of a number is always positive. So both these conditions cannot be true simultaneously. Therefore we can say that A is a empty set. Another classification is finite and infinite sets. Now based on the number of elements a set contains, we classify the set into finite or infinite set. So finite means having countable number of elements. For example, if A is equal to 1 2 3 4 5, so we can see that A has 5 elements, so this is a countable, and hence it is a finite set. And if we denote B as a set of points on a line, then you know that a line has infinite number of, line means a line की definition यही है कि it is a collection of infinite number of points. So these points cannot be counted how many these are, and so this B set represents a infinite set. So finite empty set is also a kind of a finite set only because it has 0 elements, so this is again countable, and the countable number of elements, that is finite set. Another type of set is in equal sets. Equal set, two sets are equal if they have same elements. If every element which is in A is also in B. These, for example, if we have considered two sets A and B, and if every element of A is an element in B, then both the sets are equal. For example, another example we have taken 1 1 2, and if B is equal to 1 2, then we can see that 1 and 2 both are in A and these both are also in B. So we can see that number of elements may not be same even if the sets are equal, right? Then coming to a subset. Now subset means a sub part of a set, right? So if we say that A is a subset of B if and only if A element belongs to A implies that A also belongs to B. Now for example, if we denote a set A as a set of all the students in your class and B as all students in your school, so we can see that the class is also part of a school, right? So we can see that A is a subset of B. Now if A is a subset of B and B is also a subset of A, if and only if A and B are equal, means what? If we can say that A has elements which are a part of the set B and B has also the element which are part of A, so which is only possible if both the elements in the A and B are same, right? So another point to be noted in case of subset is if A is a subset of A and phi is a subset of every set, because empty set, so I'm going to tell you how you write the subset. For example, if A set is written as 2 3 4 5, so what are the subsets? The subsets of A are 2, right, 2 3, right, then 2 3 4 and 2 3 5, and also and phi is also a kind of subset of A. So these are the subsets of the set A. Subset means a part of a set. This is a whole complete set, so part of set could be 2, or a combination of 2 elements, a combination of 3 elements, combination of all the elements. It could be like 2 4 5, which we haven't written over here. So combination of basically elements represents a subset. Now if A is a subset of B and A is not equal to B, then A is called a proper subset of B and B is a superset of A. Means what? If A is represented as, let us say for example 1 2 3 and B is equal to 1 2 3 4 5, so we can say that this set B has the complete set A 1 2 3. This, so we can say that A is a subset of B, so this is a proper subset. Means what? B has the set A as well as some additional elements, so this is a proper subset of B. A is a proper subset of B and B is a superset of A. Superset means it has the set A as well as some additional elements, right? Then we coming to the topic intervals. If A is equal to, interval means a range of elements, range, right? So A, if set A is equal to Y such that Y lies between A and B, is an open interval. Acha, I'm going to tell you one thing. A range, if we have these brackets, right, so this represents that, for example, if we write here A B, so this represents means all the numbers between A and B without including the endpoints A and B, right? So if this square bracket is used, then we can say that all the elements including the A and B. So these are the representations, right? Now if Y lies between A and B, then we can write represent this over a straight line. This represents an interval, that Y is in between A and B, right? So now for example, if A is a set having a range or interval -3 to 5 and B is a interval from -7 to 9, we can see these kind of brackets are used. So this means that -3 and 5 are not the part of set A, and range, we can say that, and this indicates that -7 and 9 are a part of this set. So what we can see over here, we have just represented this over a line. So this A set is between -3 and 5, this is set A, and B set is from -7 to 9. So we can see that, so this range is a part of the wider range -7 to 9. So we can say that A is a subset of B, right? So these are the general representations. So these are just from example, if we want to represent the non-negative real numbers. Non-negative means without having negative numbers, right? So 0 से लेकर के infinity तक, so this number line we can say draw, and we can say this 0 is also included in the non-negative numbers. So 0 से लेकर के infinity तक, and then minus infinity to infinity, this range represents the nothing but real numbers. So minus infinity से लेकर के infinity तक, 0 is in between, and minus infinity to 0, this represent negative real numbers, right? These are just representations. Next, coming to power set, this is another classification. If A is a set of two numbers, two elements 1 and 2, so we can write all the subsets of A as A is equal to phi. Phi is we have discussed that phi is a subset of every set, right? This is element 1 2, and then arranging both these together, this is 1 2. So इन्हीं का जो set हुआ, मतलब subsets का set, these are nothing but subsets, राइट? सो सबसेट्स के सेट को ही हम लोग क्या बोल देते हैं, पावर सेट. सो वी डिनोट दिस एज पावर पी ब्रैकेट में ए, दिस द पावर सेट ऑफ ए मीन्स सेट ऑफ ऑल दीज सबसेट्स. Now one thing we can observe over here, that power set of A has 4 elements, right? These are 1 2 3 4. So we have written this, that number of elements in power set A is equal to 4, and we can see that 4 is nothing but 2 raised to power 2. So 2 यहाँ पे जो पावर आएगी, that is the number of elements of set A. Means this is a general observation we have seen. If for example number of elements in set A will be determining the number of elements in the power set. For example, if element set A has k number of elements, then we can say that number of elements in the power set will be 2 raised to power k, and vice versa, right? Next, coming to universal set. Universal set means basic set from which all other sets are a subset, of which all other sets are a subset. For example, n is a subset of natural numbers, and if we write a is equal to 1 से लेकर के 100 तक, then we can say that universal set for a will be n, right? So universal set means basically it is a kind of a source of all the sets, right? So we can represent this as follows, that this representation of a universal set is by indicated by a rectangle, and then subset of a universal set is represented by a circle inside it, and we have written this as A. So these 1 2 3 से लेकर के 100 तक, and then U we have represented as universal set. So the rectangle, this is a representation in mathematics, that rectangle represents the universal set, and circle inside the rectangle represent the subset of U, right? So this is also called as Venn diagram representation, which we are going to discuss now.